Today we are going to be learning about multiplication equations. Let's make a connection. Use what you already know about numerical and algebraic expressions and equations to help you learn multiplication equations. Remember, an equal sign shows us that we have an equation. An equation has an equal sign to show that two amounts are equal. Remember, and that's the difference from us having an expression. An expression does not have an equal sign, but an equation does. If we're going to look at the first example, we have 7 times 3 equals 21. 7 times 3 is 21, and 21 is equal to 21. So this equation is balanced. This also says that 7 groups of 3 is 21. Let's complete this model to balance this equation. First, we're going to look at the left side of the balance. The left side of the balance shows 1, 2, 3, 4 ends. And we know that this is multiplication. We can write multiplication 4n this way, or we could use the actual multiplication symbol and we can write 4 times n this way. We need to make sure that this side, the right side, is equal or equivalent to the left side. So we're going to take our group of ones that's here and we're going to move them onto the right side of the balance so that we can show that they are equal. When I'm looking at my group of ones, I need to figure out how many are actually here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I have 4 rows, 6 in each row. And I know that that is going to equal 24 when I count them all together. 4n equals 24. We're not going to solve for the variable n or try to figure out what n is, but if we really thought about it, we could solve for that, and that would let us know that this indeed is a balanced equation. Both sides are equal or equivalent to each other. Let's look at some word problems. Let's look at this first word problem. We're going to apply what we're learning to this word problem to make it a multiplication equation and a multiplication model. Sarah is making a number of bracelets to sell at the Old Florida celebration of the Arts Festival in Cedar Key, Florida. Each bracelet uses 6 beads. She has 24 beads. How many bracelets can Sarah make? I need to think to myself, what is this problem even about? This problem is about Sarah making some bracelets to sell at a festival. So I need to next figure out what I need to keep in this problem. This problem is what I call a problem that has too much information, TMI. Some of this stuff we do not need. So we're going to eliminate what we don't need and keep what we need. Now, what is this problem asking us to do? What is the question asking us to find out? We want to find out how many bracelets can Sarah make. What information within this word problem helps me solve for how many bracelets she can make? So that's what I'm going to focus on. Sarah is making a number of bracelets. I'm going to stop here and I'm going to keep this information. She's making a number of bracelets. I need to keep that phrase because this tells me what words represent the unknown. These words, a number of bracelets, represent what's unknown. It doesn't tell me how many, so this is what's going to be unknown. And I'm going to choose a variable. Since we're talking about bracelets, I'm going to choose a variable B. So a number of bracelets to sell at the Old Florida Celebration of Arts Festival in Cedar Key, Florida. That's a mouthful, and I don't need that information. So I am going to eliminate this information because I do not need it in order to solve. Each bracelet uses 6 beads. She has 24 beads. I need to know that for each bracelet, I need 6 beads. I also need to know that she has 24 beads, so I need to know the amount of beads that Sarah has. This information is going to help me solve for how many bracelets can Sarah make. There's two things that I want you to be aware of. Do not get confused or caught up in this word sell and this word uses. Those two words identify our subtraction problems when we are working with subtraction. However, this problem has nothing to do with subtraction. I know that because I'm trying to solve for how many bracelets she can make based on the fact that she has 24 beads and that each bracelet that she makes is going to need 6 beads. So there's some information that I know that's going to help me determine what type of problem this is. This is a multiplication equation. So I'm going to say a number of bracelets, B, times 6 beads on each bracelet equals, because she has 24. So this is going to be my equation. Now, I am solving for the number of groups. I don't know the number of groups. The number of groups is the unknown. Remember when we're looking at a multiplication problem, B times 6 equals 24. The first factor tells us the groups. The second factor tells us the number in each group. And then, of course, this is our total. So I don't know the number of groups. That's what I'm looking for. So when I'm drawing a model, identifying the number of groups, I need to identify the information that I do know. I know that she has to put 6 beads on each bracelet. I know that the total is going to be 24. So those things I know. What I don't know is this part right here. I don't know what this part is. This piece, I don't know. So this is going to show my unknown groups. So we're just going to simply call it B groups. So that's what we're going to put here. This is going to be B groups, just like this, because this is the part that I do not know. Okay, this shows my equation, B times 6 equals 24. This shows my model, B groups, so it's unknown groups, times 6 is 24. Let's look at our second multiplication problem. Jaya has 4 bracelets. Each bracelet has the same number of beads. She has a total of 24 beads. How many beads are on each bracelet? This problem is about Jaya, and she has some bracelets. Okay? And she has a certain number of beads on each bracelet. Okay? Now, we are going to see what information we need to keep and if there's any information that we can eliminate. This problem is not as wordy as that first one that we had. So we're solving for how many beads are on each bracelet. So if I'm solving for how many beads on each bracelet, I know that she has 4 bracelets, and I know that each bracelet has the same number of beads. Now, I don't know how many beads are on the bracelet. So again, I am going to take this information here, has the same number of beads. So each bracelet, I don't know how many. I just know that they have the same number of beads. So that is going to show my variable. She has a total of 24. That's going to equal 24. She has a total of 24. Now, I am going to recognize that this time I am looking for the number in each group. I don't know the number in each group, but what I do know is that the total number of bracelets she has is 4. That's how many bracelets she has. 4 bracelets times a number of beads on each bracelet. Okay, the same number of beads on each bracelet equals 24, which is our total number. Then I need to take this and put it into a model. Since I'm looking for the number in each group, I'm going to model this a different way than before. 4 times b is familiar to us. We remember making our multiplication expression, and we divided our rectangle into the equal parts, and then we put our variable inside of each of the parts. That remains the same. Now we're going to take our total to show that it equals 24, and we're going to put our 24 here. And that would show the model 4 times b equals 24. This describes the words from the word problem. Now let's practice some multiplication models. This model is going to show the number in each group. When we know the number in each group, the unknown is the number in each group. So we don't know. This is the unknown. The unknown is the number in each group. 4 times z, or 4z, we would keep that model just like we did when we were doing the expressions. We showed 4 groups, and we would place z in each group, and then the total would be 12. Okay, let's try that again. See if you can pause the video and do 5f equals 25. Five f equals 25. So we have f's represented in each of the boxes. It's 5 times f. And then 25 is the total. Did you get that correct? If you did, great. If not, we'll have some more practice on your homework page. Now the unknown is the number of groups. So we don't know the number of groups. So this time we're going to represent the things that we do know. We know that, okay, I'm sorry, I am not doing this correct. Let me make a correction. That is not n, because n is the unknown. That's what we're trying to figure out. We don't know that. But what we do know is that there are 9 in each group. We just don't know how many groups we have. So this is going to show our n groups, because that's what we don't know. This is n groups. We don't know that. But we do know that 9 times whatever the groups are, so we have our n groups, and that is going to give us a total of 27. So this is what we do know, this information here. Okay, now that I have that drawn correctly, see if you can pause the video and do g times 8 equals 40. Remember, the unknown is g, which is the number of groups. So you should have a model that looks similar to this one. Okay? We don't know the number of groups, G groups, so we know 8 times G groups is 40. We don't know what those groups are. So this is what you're going to practice. Remember to say, Ms. Clemens, I have watched the video on Edmodo. Take care of your whisk and do your homework page. Make sure that you have written down any questions that you have, and that is part of your whisk. See you tomorrow in class.